Imagine a robot standing in front of you. How does it know what's happening around it? How does it decide what to do next? Is it just following commands or is it actually thinking? The answer lies in one of the most important concepts in AI: intelligent agents. Welcome back, everyone. In today's lesson, we are going to learn one of the core concepts in artificial intelligence: intelligent agents and the perception action cycle. Before AI can solve problems, play chess, recommend movies, or drive a car, it first needs a way to observe its environment and respond appropriately. That's exactly what an intelligent agent does. By the end of this lesson, you will understand what an agent is, how an agent interacts with its environment, the role of sensors and actuators, what perception and action mean in AI, why the perception action cycle is the foundation of intelligent systems. Let's begin with the most basic question. What's an agent? We can say an agent is anything that perceives its environment through sensors and acts upon that environment through actuators. Notice something important here. An agent doesn't have to be a robot. It can be a software program, a chatbot, your smartphone assistant, or even a thermostat. Every intelligent system follows this basic process. First, it observes the environment. Next, it processes the information. Finally, it performs an action, right? Sensors are how an agent receives information from its environment. They collect data about what's happening around the agent. What are the examples? If an agent is a human, sensors are the eyes, ears, nose, and skin. What about self-driving car? Sensors of a self-driving car are cameras, lidars, radars, GPS. Sensors of a robot are camera, infrared sensor, ultrasonic sensor, etc. Sensors of a smartphone are the camera, microphone, GPS, and accelerometer, and etc. Right? Sensors of a chatbot are the user's text or voice input. Without sensors, the agent is effectively blind. It has no information about its surroundings. This question mark represents the agent's decision-making process, often called the agent program or AI model. It performs tasks such as processing information, applying rules, running machine learning models, planning, choosing the best action. This is essentially the brain of the agent. It takes the information from the sensors, analyzes it, and decides what to do next. Actuators. Actuators are the components that allow the agent to affect or change its environment. What are the examples for actuators? First one, self-driving car. Actuators of a self-driving car are steering, brakes, accelerator. What about a chatbot? Actuators of a chatbot are display text or generate speech. What about a drone? Actuators of a drone are propellers. Actuators of a robot are wheels, robotic arms, and motors. What about human? Actuators of a human are legs, hands, mouth, and etc. Without actuators, an agent could observe everything, but would never be able to respond. Environment. The environment is everything outside the agent that it can observe and interact with. What are the examples? Road for a self-driving car, chessboard for a chess AI, internet for a chatbot, smart home for Alexa, classroom for teaching robot. Notice the arrows. The environment sends information to the sensors. The agent processes that information, makes a decision, and sends commands to the actuators, right? The actuators then perform an action that changes the environment. Once the environment changes, the sensors collect new information and the cycle repeats, right? This continuous loop is called the perception action life cycle. It allows intelligent agents to continuously observe, think, act, and adapt to changing situations. Let's take real-life examples. Use a self-driving car. We can represent it like this. Notice how the cycle never stops. Every second, the car perceives, decides, acts, and perceives again. This is another example for a human. We can represent scenario like this. Remember, humans are also intelligent agents. We constantly perceive our surroundings, make decisions, and acts. Now that we understand what an intelligent agent is and how it uses sensors and actuators, let's look at how these components work together continuously. This continuous process is called the perception action cycle, and it is one of the fundamental concepts in artificial intelligence. What is the perception action cycle? The perception action cycle describes the continuous interaction between an intelligent agent and its environment. Instead of acting only once, an intelligent agent repeatedly observes its surroundings, processes the information, takes an action, and then observes the results of that action. This cycle continues for as long as the agent operates. The first stage is perceive. During perception, the agent collects information informations about its environment using its sensors. This information is called a percept. A percept is simply the data received by the agent at a particular moment in time. For example, if a robot's camera detects a red object, that image is a percept. If a chatbot receives the text, "What is artificial intelligence?" that user message is also a percept. Every piece of information the agent receives becomes input for decision making. Without accurate perception, an agent cannot make good decisions. After collecting information, the agent enters the think stage. This is where the agent processes the percepts, interprets the situation, evaluates possible actions, and selects the most appropriate response. Depending on the type of intelligent agent, this decision-making process may involve simple rules, search algorithms, planning techniques, probability models, or machine learning algorithms. Think of this as the agent's reasoning process. Just as humans use their brains to analyze information before acting, an intelligent agent uses its internal program or AI model to determine what to do next. Once a decision has been made, the agent performs an action through its actuators. The purpose of the action is to influence or change the environment in a way that helps achieve the agent's goal. Examples: robot picks up an object, self-driving car applies the brakes, chatbot generates an answer, smart thermostat turns on the air conditioner, chess AI moves a piece. The action taken by the agent changes the environment. This creates a new situation which the agent must observe again. Why it's a cycle? Notice that the arrows from a loop rather than a straight line. This is because intelligent agents operate continuously. Every action changes the environment, and every change creates new information that the agent must perceive again. This feedback loop enables intelligent agents to adapt to changing environments instead of making only one decision. Why is the perception action cycle important? The perception action cycle is what makes an agent intelligent rather than merely automated. Instead of following a fixed sequence of commands, the agent continuously reacts to changes in its environment. What are the benefits? Adapts to changing situations, corrects mistakes using new information, makes informed decisions, operates autonomously, supports real-time decision making. Consider self-driving car. Notice that the process doesn't stop after braking. The car keeps observing the environment and making new decisions every fraction of a second. The next example. Consider robot vacuum. We can represent processes like this. A robot vacuum constantly senses obstacles, plans a safe route, moves, and then senses again. This repeated interaction is the perception action cycle in action. The next, consider a ChatGPT. Even conversational AI follows the same principle. Each user message becomes a new percept, which is processed before generating the next response. One important thing to remember is that every action changes the environment. Once the environment changes, the agent receives new information, which may lead to a completely different decision. This ability to continuously adapt is what distinguishes intelligent agents from simple programs that execute a fixed sequence of instructions. Imagine you're crossing a busy road. You first look left and right. That's perception. You decide whether it's safe. That's thinking. You begin walking. That is action. Halfway across, a motorcycle suddenly approaches. You immediately observe the new situation, think again, and perhaps step back or speed up. This repeated observe, think, act process is exactly how the perception action cycle works. Can you identify the components of a smart thermostat? Please try on your own. The next main topic is type of agents. Let's begin with the simplest type of intelligent agent. First one, simple reflex agents. A simple reflex agent chooses an action based only on the current percept, without considering past experiences or future consequences. In other words, it follows predefined condition action rules, often called if-then rules. These are the examples. Direct mapping. Direct mapping means there is a direct connection between what the agent perceives and the action it performs. The agent does not analyze previous events or predict future situations. It simply reacts according to a predefined rule. We can represent it like this. What are the characteristics? Uses only current percept, no memory of previous percept, no planning, fast decision making, works well in simple, fully observable environments. What are the real life examples? Automatic doors, smoke alarm, motion sense lights, thermostat, automatic soap identifier. For example, when the motion sensor detects movement, it immediately turns on the light. It doesn't remember who entered the room or predict who might enter next, it simply reacts. What are the limitations? Simple reflex agents work well only when the environment is simple and fully observable. They cannot handle situations that require memory, planning, or reasoning about future events. For an example, a self-driving car cannot rely only on reflexes because it must predict traffic, pedestrians, and other vehicles. Many real-world problems require more than simply reacting. Sometimes an agent must decide which action will help it achieve a specific objective. This brings us to goal-based agents. This is about a transition. The next type is goal-based agents. A goal-based agent makes decisions by considering a goal that it wants to achieve. Instead of reacting immediately, it evaluates different possible actions and selects the one that best moves it toward its goal. We can simply say goal-based agents maintain an internal model of the world to plan. An internal model is the agent's representation of the environment. It helps the agent understand the current situation and predict how its actions may change the environment. Example, GPS navigation system knows your current location, road network, traffic conditions, destination. It uses this information to plan the best route. What about planning? Unlike a simple reflex agent, a goal-based agent thinks ahead. It considers different possible actions and predicts which one is most likely to achieve its goal. We can represent it like this. What are the real-life examples? Self-driving cars, delivery robots, GPS navigation systems, warehouse robots, chess playing AI. For an example, a chess AI asks, if I move this piece now, what will happen several moves later? This is planning rather than reacting. Let's take an example for the goal-based example. The goal is reach destination. What about agent? Agent detects traffic, predicts congestion, chooses an alternative route, and recalculates if conditions change. Notice that the agent is not simply reacting to traffic. It is planning a route that still achieves its goal. Find the difference between reflex vs goal-based agents. You should remember this. Reflex agents are reactive and goal-based agents are proactive. Reactive means the agent responds immediately to what is happening right now. It does not think ahead. This is the example for reactive. Proactive means the agent considers future outcomes and plans actions to achieve a goal. For an example, a delivery robot plans the shortest route before it starts moving and changes its route if an obstacle appears. Imagine you're hungry. According to simple reflex, you see food and you eat it immediately. But in goal-based agent, you want to eat healthy and you compare severals and you choose the healthiest option because it helps achieve your goal. Both agents respond to the environment, but only the goal-based agent thinks about the desired outcome before acting. So far, we've learned about intelligent agents and how they perceive, think, and act. But not all agents are physical robots. Some agents exist entirely in software. These are called bots. What's a bot? A bot, short for robot, is a software program that performs tasks automatically. In artificial intelligence, a bot is considered a software agent because it perceives information, processes it, and performs actions without requiring continuous human intervention. Unlike a physical robot, a bot has no wheels, arms, or cameras. It operates entirely in a digital environment, such as a website, messaging platform, or computer system. Where do bots operate? Instead of interacting with the physical world, bots interact with digital environments. Examples: websites, mobile applications, messaging platforms, social media, online games, cloud services, business systems. For bot, the environment isn't a room or road. It's a digital system where it receives information and performs tasks. How bots receive information? Just like a robot uses sensors, a bot has digital source of information. These act as its sensors. First one, reads text. Example: when you send a message to ChatGPT or a customer support chatbot, your message becomes the HOTS input or percent. The next one, detects clicks. Example: a shopping website bot may detect when a customer clicks track order and use that information to provide shipping updates. The next one, receives API data. Bots often communicate with other software using APIs, which allow applications to exchange information automatically. Example: a weather bot requests current weather data from a weather API before replying to the user. How bots make decisions? After receiving information, the bot processes it to determine the most appropriate response or action. Examples include rule-based logic, decision trees, search algorithms, machine learning, large language models. For an example, customer asks, "Where is my order?" The bot understands the question, retrieves the order information, determines the shipment status, generates an appropriate response. This is the bot's reasoning stage. It transforms input into meaningful decisions. How bots respond? Finally, the bot performs an action based on its decision. What are the examples? First one, send messages. For an example, a customer service chatbot replies with an answer. The next one, updates databases. For an example, a banking bot records a successful transaction in the database. The next one, displays information. For an example, a weather bot displays today's forecast after retrieving weather data. What are the other common actions? Send emails, schedule meetings, recommend products, process payment, create reports, trigger notifications. Although bots don't move like robots, They still act by changing information or interacting with software systems. Notice that bots also follow the perception action cycle. They continuously receive new information, process it, take an action, and then wait for the next input. Consider ChatGPT. ChatGPT is an example of an AI-powered software agent. It continuously receives prompts, processes them using a large language model, and generates responses. Consider customer support bot. Many companies use customer support bots to answer common questions automatically, reducing response times and improving customer service. The next one is weather bot. The bot doesn't know the weather by itself. It retrieves the latest information from a weather service through an API and presents it to the user. Find the difference between bot and physical robot. Both are intelligent agents because they perceive, process, and act. The main difference is the environment in which they operate. We learned that bots perceive information, think, and then act. But what exactly happens during the think stage? One of the simplest ways a chatbot makes decisions is through intent mapping. Intent mapping is the process of identifying what the user wants and connecting that intention to the most appropriate action or response. In simple chatbots, the bot doesn't truly understand language like a human. Instead, it tries to recognize the user's intent and then selects a predefined response or action. What is an intent? An intent represents the user's goal or purpose behind a message. It answers the question, what does the user want the bot to do? Notice that different users can express the same intent in different ways. Example, where is my package? Track my order. Has my order been shipped? Like this. Although the wording is different, all three messages have the same intent. Checking the order status. If our message is hello, the intent should be greeting. The intent should be get weather. What is mapping? Once the chatbot identifies the user's intent, it maps that intent to the correct action or response. Mapping simply means creating a connection between an intent and what the bot should do next. These are the examples for the mapping. Notice that intent mapping happens during the think stage of the perception action cycle. The bot receives the user's message, identifies the intent, decides what action matches that intent, and then performs the action. Example 1. If user says, I forgot my password, the bot processes it like this. If user says, will it rain tomorrow? The bot processes it like this. Why is it called Intent mapping. The word mapping means creating relationship between two things. In chatbot development, we map one user intent to one appropriate action or response. We can represent it like this. What about rule-based intent mapping? Many basic chatbots use predefined rules. If the detected intent matches a known category, the chatbot executes the corresponding action. This approach is simple, fast, and effective for common tasks, but it can struggle when users ask unexpected questions or raise requests in unusual ways. Modern AI chatbots still identify the user's intent, but they are not limited to fixed rules. They use natural language processing and machine learning to understand different ways people express the same idea. Example, all of these express the same intent. What's today's weather? Will it rain today? Do I need an umbrella? How's the weather outside? A rule-based chatbot might need separate rules for each variation, whereas an AI-powered chatbot can often recognize that they all refer to the same underlying intent. Intent is not the exact sentence that the user types. Intent is the meaning or purpose behind that sentence. Example, user says intent hi. If user says hi, intent is greeting. If user says hello, greeting is intent is greeting, right? If user says good morning, intent is greeting. Hey there, intent is greeting. Different words can express the same intent, right? Sorry for the mistakes. Let's quickly recap what we've learned today. We discussed what an intelligent agent is, how it perceives, thinks, and acts, explored different types of agents, learned about software bots, and understood the concept of the intent mapping. These are fundamental building blocks of artificial intelligence, so make sure you understand them before moving on. Thank you for watching, and I'll see you in the next class. Bye bye.